Welcome once again to our revision of the topic statistics, and today I want us to look at the median and the quartiles from ungrouped data. A number of times I've seen candidates having a challenge with this area. Many resort to calculation, yet the process is so simple and may not require any calculation, just counting of numbers. If you recall in Form 2, you are told that the median is the number that is lying in the middle when the data is arranged in ascending or descending order. So the first step will require that we arrange the data that is given in ascending or descending order, but for today I will want us to stick to just ascending order so that we get used to one way of doing it. Ascending order. Even for the quartiles, we shall look at the lower quartile, the upper quartile, and quartile deviation. In all these cases, we shall be arranging the data in ascending order, then we pick the median, we pick the quartiles, then we determine the quartile deviation. So it is a simple process. We'll look at two examples. The first example is here. Determine the median, interquartile range, and the quartile deviation for this data. So the data is here. It is not arranged in any order. So the first step is arrange in ascending or descending order. For now, I've said we shall go by the ascending order. So the least number here is 1. 2. We don't have a 3. So the next number is 4. And you can see 4 appears twice. For this purpose, we list it 2 times. So 4 and 4. The next number is 5. You check through if it is appearing once, like in this case it's appearing once, so 5. Then the next number is 6. I can see 6 is appearing twice, so you list it twice. Then the next number is 7. 7 equally appears twice, so 7 and 7. 8 appears once. And 9. You confirm that you have listed all the numbers. One way of confirming is counting all these numbers. How many are there? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 numbers. Now, we learned something in Form 2 that when we have an odd number of items, then only one number appears in the middle. So like if there are 11, to get the number in the middle, you use the formula n plus 1 over 2, where n is the number of items 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it is 11 plus 1 over 2, which gives us 6. So it means the 6th number is the number in the middle. So when we're looking for the median, 1, 2, 3, 4, 5, 6, the 6th number you'll realize that that number divides the data into two equal halves. It is the number in the middle when the data is arranged in ascending or descending order. You will see 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our median is equal to 6. You can see how simple it is, no calculation, just arranging the data and picking. Now once we have picked the median, then the data is now divided into two halves. This side is called the lower half. And this other side is called the upper half. So, when we are looking at the quartiles, we are supposed to get the lower quartile and the upper quartile. The lower quartile which by now you know is denoted by Q1, is like the median of the lower half of the data. You can see the lower half has 1, 2, 3, 4, 5 numbers. So the number in the middle of the 5 is the median of that lower half, and that is the Q1, the lower quartile. So you can see, even if we use this formula n plus 1 over 2, the lower half has 5 numbers. So 1, 2, 3, 4, 5. 5 plus 1 will be 6. 6 divided by 2 is 3. So the third number will be the middle number in the lower half. So that will be our Q1, lower quartile. So lower quartile will be 4. When you go to the upper quartile, which is now Q3, it is the median of the upper half, which has these numbers 1, 2, 3, 4, 5. And you can see from the listing, the number in the middle here will be 7. It divides the upper half into 2 equal parts. This 4 also divides the lower half into 2 equal parts. So this is our Q3, the upper quartile. So our upper quartile is 7. So the question was asking us for the median, which we have already got. Interquartile range. Interquartile range is Q3, the upper quartile, minus Q1, the lower quartile. So this is 7 minus 4, which is 3. You can see it is simple calculation, although it is a challenge to a number of students. That is the interquartile range. 7 minus 4 giving us 3. You can see so far no calculation has been done. And the last one is now quartile deviation. This one is challenging to candidates simply because of the term quartile deviation. Otherwise, you are aware that quartile deviation is also called semi-interquartile range. Quartile deviation, also called semi-interquartile range. So quartile deviation is equal to Q3 minus Q1 over 2. Upper quartile minus the lower quartile divided by 2. But remember, we have already got the upper quartile minus the lower quartile, which is 3. You divide by 2, you get 1.5. So that becomes our quartile deviation. Sometimes you find candidates have left that blank because they don't understand what quartile deviation is. But I want you to note that when the data is not grouped, there is no calculation to be done. It is a matter of arranging the data in ascending or descending order, then picking as we have done. Let us look at the example number 2. The production of milk in liters of 14 cows on a certain day was recorded as follows. So these are the liters of milk produced by the 13 cows. One is producing 22, 26, another one is producing 28. We can just confirm that there are 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Determine the median. Since it is 14, it means that the number in the middle is obtained by use of the same formula that we have said there. To get the number that the position, the middle position, we shall take n plus 1 over 2, the position of the median. And since there are 14 numbers, n is 14, so 14 plus 1 over 2 will be 15 over 2, which is 7.5. What does 7.5 mean? It means that the middle number will be lying between, the median will be lying between the 7th and the 8th numbers in this data, if arranged in ascending or descending order. The middle position will be between the 7th and the 8th. That is why it is coming out as 7.5. So our first step, let us arrange this data in ascending order. We can scan through and see which is the least. The least is 15. You check if it appears once or twice, you list it twice, so it is appearing twice, so you list it twice. The next number is 16. You confirm if it is appearing more than once, it is not. So we are through with 15. You can tick. The next number we can see there will be 19. You check it's appearing more than once. There's another 19. There is 20. So 20 once, 22, 21. 21 is appearing once. And we check on 22. 1, 2, 3. So 22, 22. We check if there is a 23, no. So the next is 26. Appearing once. There. Then 27. Appearing once, then 28. You must be keen in listing, and here we have listed. So we know that between the 7th and the 8th, that is where the median will be lying. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So the median is lying in between here. 1, 2, 3, 4, 5, 6, 7. This is the position where the median lies. Between the 7th and the 8th. So here we shall say that the median for this data is equal to 20 plus 21 divided by 2. The median is 20.5. You can remember that this data is even. And if it is even, then the median will be lying between two numbers, the 7 and the 8. That is the position of the median. That is why we are now adding the 2, dividing by 2 to get the median. We are asked for the interquartile range, but for the interquartile range, we must get the lower quartile and the upper quartile. So now that this is the median, the data is divided into two halves. This is the lower half, this is the upper half of the data. So the lower half has 1, 2, 3, 4, 5, 6, 7 numbers, which is odd. So it means that the median of the lower half is the number that will appear in the middle. Let us see. 1, 2, 3. 1, 2, 3. So the middle number is going to be this, the fourth number. We have 3 on this end, 3 on the other end. So that is our Q1. So lower quartile Q1 is 19. Upper quartile Q3 is now the median of the upper half of the data, which again will be the number in the middle, 1, 2, 3, the fourth one. So that becomes our Q3, which is 22. So interquartile range is 22 minus 19. Coincidentally, it is 3 again, but that is just a coincidence. Don't assume it will always be 3. And then the quartile deviation is when you divide the interquartile range by 2. That you can now complete. So that is how we get the median, we get the quartiles when data that is given to us is not grouped. Don't struggle with calculation. Just go to that list the numbers, preferably in ascending order because that is what we are used to, then pick. But I've said for odd number of items, you will realize that only one number is in the middle. So you first of all identify that number in the middle so that it divides the data into two equal halves. You get the median of the lower half, which is the lower quartile, then the median of the upper half, which is the upper quartile. For even data, the median will be falling between two numbers. So you will add and divide by 2. But first, list and arrange the number in ascending or descending order. So in the next class, we are going to look at the use of the ogive in determination of the median and even the quartiles. Thank you and may God bless you.